This is our fully automatic 2-axis 485 series machine. 2-axis machine means in this machine the feeding is servo based, fully automatic, and the cutter movement is also servo based. There is a servo motor up here and it is fully programmable. In this machine, the kind of a program that you prepare, this is the program that you prepare for one particular pipe to cut. You give a name to the program. You can note down the RPM that you want to cut, the blade thickness, numbers of pipe that you wish to cut. You can also cut 5 different lengths from 120 feet. Here, for the specific program, you note down the cutter movement, which means that this particular machine will have a variable feed from top to bottom. Say for an example, here you can see there is a gap, which is an air gap. So that air gap, it will travel very, very fast. On the top of this cutting, there is a lesser amount of load, so it will go faster. On middle, there is a higher amount of load, so it will go slower, and on the bottom again, it will go faster. So basically, according to the load, the feed rate can vary, which will give you a higher blade life and higher productivity. So this is a fully automatic 2-axis machine. This is a high-speed machine, which means that the feeding system can travel 1 meter in just 1.2 seconds. I'll show you. Here you can see the travel of the feeding system. It will cut variable lengths as has been programmed. One meter travel in just 1.2 seconds. So it will save in a lot of your productivity. It will increase a lot of your productivity. Variable feed also increases the blade life by 30% because variable cut lengths, 5 different cut lengths from 120 feet of your input pipes. Jai Bharat, this is a basic general presentation video explaining the basic functional difference between a single axis and a 2-axis servo controlled HSS based pipe cutting machine. Here we have just put up an example for a 22 mm OD 3 mm wall thickness pipe. Normally in an automatic machine which is capable of cutting this particular pipe into a bunch of 9. Now this example we will try to understand. Now in a single axis machine, this complete travel, which if we are having 22 mm from point to point of the tube, my travel would be about 85 mm. But the cutter needs about 10 mm of a relief here and 5 mm even after cutting. So in totality, my travel will be approximately 100 mm, 99.2, that is about 100 mm. In a single axis machine, which means my cutter is traveling with a hydraulic pressure, with a hydraulic pressure flow control valve. So user has to set one feed rate according to his experience. Now that he has to set it at the rate of specific reference. So this complete travel will be at a fixed rate that it is going to travel. Normally the reference would be of a greater cutting area. As you can see here the first 10 mm the cutter is going to travel in the air. There is no material. After that, if you can see here, it is a 15 mm area where cutter is only going to encounter one single tube while cutting. Next 15 mm cutter will be, or machine will be cutting 2.5 tubes at a time. But after that 22 mm area, cutter is going to cut technically about 3.5 4 tubes at a time. Subsequently coming back, it will cut 2.5 single tube, air travel and go back. So hydraulic single axis machine will have one consistent common travel throughout this 100 mm, and that is would be the reference of this higher engaging area. This is a higher engaging area. So let us assume that by the book or by the data, for this heavier engaging area, it needs to be cut at 5 mm per second. At that rate, if the cutter has to travel 100 mm, approximate cycle time for cutting 9 tubes of 22 mm into 3, cycle time would come at about 20 seconds. So the cutting time for a single axis would be about 20 seconds. Now, against that, in a single axis machine, this complete travel is divided into 5 different feed length. So a single axis would see this job from a different perspective. Here, the first travel, which is no load, it considered as a T1. Second travel, which is only single pipe, is considered as T2, subsequently T3, T4, wherein the maximum load is there, again T3, T2, T1. So here what happens is, if by the data or by the book, if this 22 should be cut at the rate of 5 seconds, so naturally this 22 mm will require 4.4 seconds at the rate of 5 seconds for cutting this area. But for this area 15 mm subsequently, because the load is only 60%, my feed rate can increase 1.5 times, that is 7.5 mm per second. So this travel will become to 2.1 second each. Subsequently, this T2, my load is even lesser, that is only 30% of what you see here. So my travel will be 2 times of this, so that is 10 mm per second. So subsequently, see the total travel time here reduces, and here it will come very, very fast in a microsecond, such as 0.1 second and 0.2 second subjectively. So for the tube size of 22 into 3, if single axis machine, a hydraulic fed machine, required 20 seconds, if you add this total, this is just in a guideline or to explain it to you, that a 2-axis machine would require only 12 seconds to cut this. If both the machines are of the same capacity, then also just having a 2-axis machine decreases the cycle time by 50%. So this is a general data that the biggest benefit of having a 2-axis machine over a single axis machine is a much better cycle time and much better productivity rate. Secondly, if a user is using a single axis machine, he will select this feed rate through a flow control valve, which is not very precise, and there are always chances that user will make mistakes. User can change, user will keep changing, they make mistakes, they may keep higher feed rate, lower feed rate. If supposingly user makes a mistake and keeps a lower feed rate, the cycle time will increase. If he keeps a higher feed rate, it is a very good possibility that the blade life will be completely devastated, and blade breakage issue will come often. Against which, when it is servo controlled, it is password protected program which is already made as per this job and saved. You can retrieve this data, and this travel is pre-designed or pre-fixed or pre-fed. So this does not change. So irrespective of the user, this will always give you consistent result and very little possibility of any kind of breakage. There's a high risk of blade breakage, which often happens in a single axis machine. Secondly, this feed rate in a single axis machine also varies and affected by the ambient temperature. In India, we know different region has got different temperature in summers and winters. The feed rate, which is hydraulically controlled, due to the ambient temperature or the working temperature of the machine, viscosity of the hydraulic will keep changing. So say for an example, in the morning, if a user has kept one feed rate, within 2 hours of working, once the hydraulic oil becomes a little hot, like 60 degrees, the viscosity changes and it becomes a little lighter. So automatically after 2 hours, the feed rate will increase automatically. Now it is not a mistake of a user, but it is the limitation of the system. Against which servo, irrespective of the weather, irrespective of the ambient temperature or any working hours, the cycle cycle feed rate will remain consistent throughout the time, which always gives you better blade life, less breakage, and most importantly, much better productivity. That productivity can increase by 30 to even 50%. So I hope this is well explained. Thank you.